Yep, I'm ready.
Great. Hello everyone. This is Sam from New Smart Economy. Today we are glad to invite Claude from AxLabs to talk with us about DAOs in practice. So, Claude, would you mind to introduce yourself first and start your workshop?
Sure. So, hello everybody. I'm Claude. I'm a software engineer at AxLabs, as you can see here. AxLabs is a Web3 software company based in Zurich, Switzerland. We call ourselves a boutique software company because we're quite small and specialized. And we've been active in the Neo ecosystem since about 2018, so quite a long time. And our biggest contribution was or is Neo3j. You probably heard of that already. It's made up of an SDK and a smart contract development pack. And so the SDK is for interacting with the Neo blockchain, creating transactions. Is your library, is your Java library for interacting with Neo. And the dev pack, on the other hand, is allows you to implement smart contracts in Java. So it gives you a library to where you have functions that you can use in your smart contracts, and it has a compiler that compiles to Neo VM code. So AxLabs is kind of covering the Java developers in the Neo community. Our other contributions, or our latest contribution, was a grant shares DAO. So that's obviously why I'm doing this presentation here. AxLabs was heavily involved in creating grant shares with many other community members of the Neo community, but we were the main contributors on the technical side, and so it kind of makes sense that I will try to give you some hints and recommendations in this area of DAOs. Besides technical things, AxLabs is also active in non-technical matters in Neo. For example, we sometimes represent Neo at conferences or like here now at hackathons. Yeah, I think that's enough of the introduction. And I can begin with a presentation. I will first give you some more theoretical insights, which are still going to be practical for you if you intend to go into the direction of DAOs. So what I like to have first is a definition. I always like definitions. One thing, maybe, oh shit, maybe I could share these slides here. What it could do, I mean, I can't share some right now. I can't share a link with you on a channel. I could do on Discord, but I'm not sure where people are. So you could scan the QR code that you can see here, and this will redirect you to these slides, I hope. All right. And at this point, I'm going to turn off my video because my laptop is a bit weak. Okay. All right. So all eyes on the slides. So first of all, what is a DAO? I recently checked the definition on Wikipedia, and I kind of liked their newest definition on what a DAO is. I'm not sure if it was different like 1 or 2 years ago, but it now says that it's an organization that is fully or partly managed by a computer program. And that's, of course, very generically put. In our case, or in most cases, it's governed by a set of smart contracts on a blockchain, right? But there's of course more than just a computer program around the DAO, right? There's always people involved. It's an organizational form. So the question is, what things are part of that computer program? And I will break it down to basically mostly voting and financial aspects of the organization, right? So these are two things that you can put on blockchain very well. Voting is something that has to do with numbers, and finances has to do with numbers, and that's why it fits well into a technical context. And that's what we see in the wild as well. Mostly what we have in DAOs on the blockchain is voting mechanisms. and we have some kind of a treasury that holds funds, and the voting part, the governance part, that has power over this treasury. And another important part of DAOs, of course, is that it's member owned. Usually there's no centralized leadership in DAOs, at least in the most idealistic way. Of course, you could have a centralized leadership also in a DAO. Maybe it's not called a DAO anymore then, but if you just appoint one member that is the owner of a smart contract that has a treasury, and that member can do whatever they want, it's probably not a DAO anymore. But it looks pretty similar, right? So what I wanted to find is a non-hype description of what a DAO is. Instead of calling it DAO, you could say it's blockchain-based tools for decentralized and democratically managed organizations. But what's purpose? Why was this created? Why do DAOs exist? And I think it's important that we first have a purpose and then come up with technical solutions. I'm not sure if this was the case with DAOs. It seems that sometimes in blockchain space, people come up with technical solutions and find a problem or a purpose for them instead of the other way around. But I think there were, DAOs do solve problems that we had and that we couldn't do before. So DAOs are made for democratic and transparent organizations of people and resources, right? We can transparently organize many people, many resources that are scattered over the world through these digital means. And as usual with blockchain, an important part is elimination of intermediaries in financial and governance processes. So when we deal with money in the DAO, we deal with voting, we can eliminate third parties, and we can do this all on the blockchain. So this saves costs, of course. The question is if we can increase efficiency of an organization through a DAO, and it depends how you look at it. From a technical perspective, I think yes, we can increase efficiency. You can set up an organization quite fast through a DAO and decentralize decision power, have a governance mechanism, have a treasury, and these things without having to come up with a legal entity, create a company, these kind of things. But efficient from a governance perspective, probably not, because DAOs usually are very idealistic, so they try to decentralize or democratize a lot, and this usually makes things slower, of course, but probably more fair. But at least DAOs allow people who are quite loosely coupled to work together, right? So we'll see some DAO examples where you can see that there's just people that have nothing to do with each other, but they can still kind of work together and trust in the process. So what is governance in DAOs? I think, of course, one of the most important things is governance in a DAO. Governance is making decisions and enforcing those decisions. And what exactly should be governed in a DAO is, like I said already, is probably financial transactions. That is something that can be done very well on a blockchain. So there should be decisions should be made decentralized about where money is spent and how how money is attracted and these things. But there can also be things that you cannot enforce on chain, but you could still vote on chain and make decisions about things that are off chain. And then it depends on, maybe you do have a legal form outside of the blockchain, and you could write in your declaration of that legal entity, you could say, okay, whatever is decided on chain has to be executed off chain as well. And so you could also have definitions of statutes. If you have an organization, you could say, okay, the statutes can only be changed if there has been some governance actions on chain, if people voted to change something. And how things are governance is a totally different question. The easiest approach has always been, or has been in the beginning, is token-based voting. So you create a token for your DAO, and you distribute a token to people, and those people who hold the token, they can vote on proposals, or they can vote on decisions of the DAO. Of course, this is not as easy as it sounds. You have to your token should have a value, right? Or people should see a value in your token. So maybe they should see it as a security, and they think that the value will rise in future, so they will buy it, and then it has some value already, and then voting makes sense only if it has value. If it has no value, anyone could buy all the tokens, and voting is useless, of course. But with token-based voting, we often see problems like plutocracy, so that big whales will have a lot of power in the DAO because they amassed a lot of tokens, and we end up with a few players in the ecosystem owning all of the voting power, and then it's not clear, of course, if they will do the right decisions for the whole community. There's some mitigations for that, like quadratic voting. I'm not going to go into that here. Other mechanisms are, for example, reputation-based voting. You could assign reputations to members of a DAO, and the better reputation, the higher your voting power is. So this would end up in a kind of a meritocracy. Sounds very nice. I would love it. I mean, I would love it for multiple different DAOs that are out there. But I think that's very hard to do because it obviously requires some kind of reputation system, which can be hard to implement. And so the easier system is to just have a one person, one vote system where whoever signs up to the DAO, they get one vote. But of course, on blockchain, this is a big problem because I can create thousands of accounts and sign up to the DAO, and then I have thousands of votes. So there's the Sybil attack problem. If you want to have this one person, one vote approach, you will probably need to do some kind of KYC. You have to know your customer or your voters, and depending on the DAO, this is impossible. If you want to onboard millions of users, that's going to be very expensive. But in case of grant shares, for example, the grant shares of the NEO ecosystem, and there we have onboarded a small group of people which everybody knows, and then we didn't have to go through KYC, right? Because those people were already known to the community. And one last thing I want to mention is random sampling, or called sortition, which is something that's been used, I think, in Athens, like in the ancient times of Athens, where they had a democratic system where they chose people by random to be the representatives in court, or for decisions, for political decisions. So that could be a solution as well. I think, again, with anonymity on blockchain, it's hard because you don't know if the people who are chosen by random will actually attend, because they're just part of the DAO, but they will not attend once they have been chosen to be representatives. So yeah, you can see there are many options, and there's no fixed solution or no one solution that fixes every problem. And then what's also very important, and I think has been neglected in the past, are these legal considerations. The problem is that many DAOs operate in a legal gray area. They often do not have actual legal entity behind them. So they are somehow an organization, right? But they haven't established an LLC or an association or something. So under law, I guess there's something like a general partnership, and it's not clear if members are aware of this, if they are aware that they are still part of a legal entity, but like not an explicit one. But it's also hard to map existing regulations onto DAO structures. It's not clear for a DAO which legal structure they should take on. Should they become a normal company, an LLC, or should they be an association? So that's why I guess many DAOs have not taken on any legal entity or legal structure. And the problem then is, of course, that there's a concern for liability. If it's not clear who is liable, is everybody liable? If I take part in what is like sushi swap, and I have tokens there, and I can take part in governance of SushiSwap, which is then an organization. Am I liable for losses of SushiSwap? If SushiSwap gets sued, who is responsible? Like, who exactly will be sued? Is it me? Is it every member? Is it the contributors? Yeah. So that's not clear, and it's a risk for all the members. Of course, also if you have a token-based voting system, then what is the nature of that token that you're issuing, right? So I think the SEC has stated in the past that tokens that are issued by DAOs could or are actually securities. I mean, it always depends. It's not sure if they also enforce such findings, but like in my eyes, also if you issue a token for a DAO and you tell your token owners that, okay, this token will probably increase in value later, then it already kind of looks like a security. So I think people have to be careful there. Yeah, there's some examples where states have come up with new regulation. There's actually a blockchain-based LLC in Vermont, the USA, and there's also other legal forerunners kind of that push to new regulations that are in favor of DAOs, or that help DAOs at least. Like many DAOs are formed as associations or foundations in Switzerland, but there's even more specific regulatory frameworks now for this. Yeah, here's just some examples of real-world DAOs. You probably know the MakerDAO. It's formed around a stablecoin, the DAI, and its goal is to provide the stablecoin for anybody, not only for members of the DAO, but for anyone. And it has a token-based voting system, so anyone can buy Maker, MKR, and take part in the governance of the DAO. And voting, what you can vote on is like different things. Well, easily said, you can vote on interest rates of the loans that are the DAI loans that MakerDAO gives away, and you could vote on collateral requirements, for example. So how much collateral somebody has to put behind a loan that they take out. Then you also probably have heard of the DAO, like the first DAO on Ethereum, which was kind of a venture capitalist fund, and I think it amassed a lot of like $140 million in ETH, but then shortly after it was launched, it got hacked, sadly, and at that time, like the losses were so bad that the whole Ethereum community decided to fork the chain. So this is very interesting. Like that Ethereum decided to fork the chain is kind of a legitimacy issue where I shouldn't really go into this now, but they kind of decided that, you know, the chain where the hacker was on was not legitimate anymore, and now the new chain is legitimate. So even, you know, it doesn't have to do anything with on-chain voting. It's just the whole community deciding that this old truth is not the truth anymore. Now this is the new truth, which is very interesting and I think very powerful in blockchain. And I have to, of course, shill grant shares here. The grant shares DAO is a grant DAO for the NEO ecosystem. And we chose a simple voting mechanism, which is basically one person, one vote. And we have a fixed set of members that can vote on proposals. All right. So let's look into some code examples on how the technical side of a DAO could look. And for this, I want to use, so I have a repository here that we also used in the past for DAO examples. And there's a branch called NEO APAC Hackathon 2023. And if you want to play along, the goal is to make this as easy as possible for anybody to check out this code and maybe do some changes and try out some stuff. So we're using GitHub Code Spaces, which is based on dev containers, I think, all these nice Microsoft products. What you can do is you can go on this code button here. And then I think for anybody, I mean, I've set up some things for myself with code spaces, but I think it's pretty straightforward for any GitHub account nowadays to start the code spaces. You can start it. Let me see here. Yeah, you can just start a new code spaces with the plus sign, and it will start a code spaces for you in the browser. So it will open Visual Studio Code, and it will spin up a Docker container somewhere in the cloud that will host the repository and all the tools and extensions. So I have one running here already. And I configured it in a way that it starts up a local instance of Visual Studio Code. Because I like to, so it's the same concept as if you would do it in the browser. It's just like the Visual Studio Code front end is local instead of in the browser, basically. So you can see that it's connected to code spaces. So I'm not actually editing code that is on my local machine, but it's in a Docker container somewhere in the Microsoft Cloud, I assume. Okay. And the nice thing about this is we, from AxLabs, we like to embed a specific dev container in our repositories. So when you do start up GitHub code spaces with our repositories, you will get like a good setup extensions that you can use for whatever code we're looking at. So in this case, we have the Neo N3 extension already installed here in this code spaces. So most of you are probably already familiar with this. You can connect to different nodes on the Neo network. You can check out the code, the block explorer right in VS Code, which is pretty cool. And you can also spin up your own nodes. Let's see if I can do this here. So this spins up Neo Express, which is a local Neo blockchain instance. And I can see which accounts are available, which wallets are available on this local blockchain. I can deploy contracts down here. So choose which blockchain, which account, and what contract you should deploy. So very nice environment for developing and trying out things. So I'm not going to go more into detail with this. Let me shut down this blockchain here. Now I'll go back to the code. So this is a simple Java repository, a Java project. We're working with Niao3j in this example. We are using Gradle as a build tool, and we can see here we import Gradle plugin for Niao3j, so we can compile our Java codes to Neo VM code. Down here, for example, we specify which Java class is the one that we should compile. So this is of course a contract implementation that we can see up here as well. And so on. We have a dev pack, and we have also a dev pack test for running, for executing JUnit tests on your smart contracts. So I'm not going to go more into details with Niao3j because Michael also from AxLabs, he did a nice presentation or workshop last week or 2 weeks ago on how to do smart contracts in Java for the Neo blockchain. So I'll share the links at the end of the presentation. All right, we can see it's a very simple setup here. We have a simple Gov smart contract. This is one contract that handles the governance for the DAO. And we have a simple treasury contract that handles, of course, the treasury handles the money of the DAO. And then we have two helper classes, which are intents and proposals. And quickly switch back here to the slides to tell you about our two contracts. So the simple governance contract, it has only a couple of functions. It stores proposals, of course. Proposals, they can have a proposer. They can have votes on it. So there's some data we need to store on the contract relevant to the proposal. Then the simple governance contract, it allows anyone to create a proposal. So there's no restrictions on who can create proposals. Anyone should be able to, as long as they can afford the gas fees, of course. And a proposal can theoretically do any on-chain action. So it's not fixed what a proposal can do. We don't have a fixed list of things a proposal can do, but a proposal could theoretically have any kinds of intents that it will execute once it's accepted, right? So when you create a proposal, you specify what the proposal will do once it's accepted. And these are all specified as on-chain actions. So you could do a swap on Flamingo, for example, and then in the same proposal, you first swap some tokens, and then you stake them, or you put them in a liquidity pool, stuff like that. So you could chain some actions together in one proposal. The contract also stores members. It's a simple contract. It's a simple governance contract with a set of members. Those members, they are script hashes, so they are wallets, like neo wallets, and they are the ones that can vote on the proposals. And we're using a one person, one vote approach here. On the other hand, there's the treasury account contract. It can receive tokens, so you can pay in neo or gas or whatever token you want, and its only function basically is to release tokens, but only, of course, when the simple governance contract requests that, right? We don't want anybody to be able to just say, oh, let's release some funds and send it to this and this address. Only if a proposal was created and was accepted by the members, and then that proposal invokes the treasury, then we want to be able to release funds. All right, back to the code. So now I'm going to step a bit through the code here. We have, you have to change specific things. We work a lot with annotations, which makes it quite clear what things are doing. We can add extra information to the manifest, for example. So who's the author, AxLabs, this kind of things. As you can see here, we have two storage maps, one's for the proposals and one's for the members, as mentioned before. These are two things we want to store in our contract. And when we deploy the contract, we already have to put in some members. This is the contract doesn't have. The contract doesn't have methods for adding new members. It's very simple. So we have to add all the members that we want to have in there in the beginning, right? When we deploy, we pass it some data, and this data is added as members. Those will be the fixed members. So if you don't add any members, then it's a useless DAO because you cannot do anything. Nobody can vote, so no proposals can pass. Then one of the most important methods is create proposal, of course. Here you can see this concept of intent. So the proposal is made up of intents and a discussion URL. The discussion URL is points to somewhere in the web and holds the discussion on this proposal. And it's not something that I would put on the chain. I think it's enough if you have a link to somewhere where information about the proposal is kept and the discussion is happening. So the intents, I want to talk a bit more about those. They, as I said before, they contain the on-chain actions that the proposal will be doing if it's approved. So let's see how we could do this. One way would be one intent holds a target contract. So which contract should be called, which method should be called, and what should be the method arguments that are passed to this method. This is something we could store or keep somewhere, and we know this is related to the proposal. And then once the proposal is approved, we can call the contract.call system. What is it called again? Just the interface on Neo. And this will then take all the intents properties, the contract, the method, and the method arguments, and it will do a call to that contract. And so we can specify the intentions of a proposal at the beginning, and then if the proposal passes, it will be executed in exactly that way. We could do this even more generically with this intent down here, which basically just has a script. So just to remind you, if I compile my contract, it's way easier to read the intent on the top, because there you can actually see which target contract is called with which methods. So it's more human readable, right? The script, you would have to kind of decompile it to check if it's actually doing what the proposal says, right? So that's all I want to say about this concept of intents. We do have the intents here. So this class represents an intent. We have this more simple approach with target contract and so on. All right. Here. All right. Here what's interesting here is, as you can see, we create a new proposal, but we actually don't pass in the intents and the discussion URL, but we hash these two things up here, and we pass the hash and store the hash in our contract. So this is not necessary, but it's one way to do it if you want to save storage and you assume that there's a lot of intents. If this array of intents is big and you don't want to store this on your contract because of gas costs, then this would be a solution where you just hash the information and you store that hash instead of all the intents. And later, when you execute a proposal, you know exactly which intents you need to arrive at that hash, right? But you could also argue that hashing, and here we're hashing SHA-256, you could also say, well, this is probably more expensive in gas than actually storing, if I only have one intent. So this is, you have to verify for this for yourself, what the costs are for this. All right, but after this, we have a proposal and it's stored on a contract. And this is when the members can start voting. They say which proposal they want to vote on. So now we always work with this proposal hash as a pointer. They say what to vote, if yes or no, and who they are, so that we check if they actually have the private key, if they signed the transaction, if they actually are this voter, and we check if this voter is one of the members. And if it is, then we can pass through here. We can get the proposal. We set either a yes or no vote on the proposal, and we put the proposal back into the storage. At any time, if somebody wants to see information about the proposal, they can, of course, also get the proposal from storage. As we have implemented it here now with hashing the proposal, of course, this doesn't give you back the intents. So there has to be somewhere, you have to make sure that the data is available somewhere, right? Okay, and then if everybody has voted, we can go and execute the proposal, or we can try and execute the proposal. So it's very simplified here. We don't have any time constraints or anything. So this would, of course, be a problem if you have a kind of a voting period. So let's say 2 members come and they vote no on a proposal. And then there's 5 more members that want to vote yes, but they take some more time. And then somebody could just execute the proposal here with no time constraints. Then, of course, it would pass, even though not all the members have voted yet. So in the end, there should be time constraints, of course, on the proposal. So if you get into this execute method here, you should check, okay, are we past the voting phase already? Are we inside of some execution phase now? To make sure that people had time to vote. All right. Apart from that, we get the intents and the discussion URL again. So that whoever executes, they have to know the intents of the original proposal and the same discussion URL that was used when the proposal was created. Because then we hash this information again, and only if we get the same hash, we will be able to retrieve the proposal again. And yeah, well, if not, then we will fail here already because there's no proposal with that hash. So, and this kind of makes sure that the intents have not been tampered with, right? The intents that have been passed into have to be the same as they have been when the proposal was first created. So we can be sure that the actions that are going to be executed down here are the correct ones. So then, yeah, simple. We add up votes to get all the votes, like the whole vote count, and then we see if there's enough yes votes. So here we're just using a simple majority. You can go more complex, of course. You could even use something like, depending on the proposal, if the proposal wants to take out funds from the treasury, maybe the votes have to be higher, like the yes votes have to be higher for a more expensive proposal, right? You can do this infinitely complicated. You'll probably also want to check how many members have even voted. If only one member voted, well, it's just going to fail because we need at least 3 members. So that's a quorum. All right. If this checks out, if we have a simple majority, then we can actually execute. Otherwise, we're going to fail here and nothing is going to happen, right? The proposal will not be executed. So and then the intents come into action. We go through all the intents of our proposal, and we do this, what I showed before, we do this contract call. And for every intent, we call the contract and the method and so on. And we also, we keep the return values of those invocations and return them after the execute method finishes. And down here, we see also an interesting method. As you probably know, in Neo, you can update your contracts, but only from inside of the contract itself, right? So we have this contract update method here. And when you look at the first line, you can see this means here that only this call to update has to come from the governance contract itself. So only if the governance contract calls its own update method, it can be updated, which means in turn that you have to create a proposal to update the contract. We have actually done that in grant shares once. We created a proposal that had a NEF and a manifest of a new version of the grant shares contract. And we put in a proposal, voted on the proposal, and then once it was accepted, the contract updated itself, which is pretty cool. Let's move on to the treasury. Treasury contract is even more simple. We have basically only one thing in storage, which is the owner key, and we set that at deploy time. And now the owner, of course, has to be the governance contract because as we said, only the governance contract should be able to do stuff with the treasury's funds. So we first deploy the governance contract, and then we take the script hash from that and we put it into the deploy method of the treasury so that the owner will be the governance contract. Then the method here on NEP17 payment, we need that just to make sure that it can receive tokens. So now with this method, you could send some NEO to the treasury, and then the treasury, it has some NEO belongs to the treasury at that point, and then they can be spent later. The most important function is release funds. Release funds takes a token, which token should be released, and who should get that token and how much. So this is just for fungible tokens. And here we do the check if whoever's calling this release funds is actually the owner. And as I said, we set the governance contract as the owner in the beginning. So only the governance contract can call this. And that means, again, only via a proposal in the governance contract, you can call this method. So everything has to go through a proposal. Nobody can tamper with these things here and just try to release funds. There's no multi-sig addresses or anything. Yeah, so that's it for code explanations here. I just want to give you one simple example of how this process could look like. So let's say somebody works for a DAO and you want to remunerate that person, you want to give them some money. So that person could create a proposal. So they would call this method here, create a proposal with an intent. That intent will not directly call, for example, the NEO contract or something, but it will call this release funds method here. So the intent will contain the script hash of the treasury. It will contain this release funds method name, and it will contain some parameters for this function. Then the members of the contract can start voting. Let's assume they will vote yes, right? In this case. And then after everybody voted, the person who created the proposal, or actually anybody who knows the intents and the description, the discussion URL, they can execute the proposal, and let's assume it passes. And so this contract.call here will then call our intent, which is simple treasury, release funds, NEO token, the person who did work for the DAO, and the amount that the DAO wants to pay them. So that's a simple walkthrough through this governance and treasury contracts. And yeah, you can see it's pretty simple, but these are kind of the main features in my regard for a DAO. If you want to work with Nia3j in Java, there's also some tests in this repository here that are based on Nia3j. It's kind of cool, in my opinion. You can say which contracts you want to test or which ones should be deployed in the test, and you can even configure the deployment here. You can say, for example, who's going to be. So here we're configuring simple governance contract, so we can say who are the members and things like this. But I'm not going to go into detail of that, just so you know that there's some examples. All right, and now let me go back to the slides. So I collected a list of links here on the last slide. Of course, the first one leads you to the repository of these smart contracts that I showed you. Then there's also a link to the workshop that Michael did just lately. This is then if you want to know more about Nia3j, that's also on YouTube. The Nia3j documentation itself is also there. And if you want to see a bit more complicated DAO implementation on Neo, you can check out the grant shares contracts. They are like what I showed is kind of a very simplified version of what you can find there. There you can also find a lot of tests. And then I think it's also very important or very helpful to look into other ecosystems or other DAOs. Here's, for example, a link for the Moloch DAO. The Moloch DAO has been around for quite some years now as well. It's kind of a venture capital fund DAO as well, similar to the DAO, but it hasn't been hacked yet. It shows some basic functionality that a DAO probably should have. And then there's Open Zeppelin governor smart contracts. Those are maybe you know Open Zeppelin. They set a lot of standards basically, so they have good smart contract examples in the Ethereum ecosystem, and they have a bit of documentation on their governor contract that could be helpful. And what I just found recently here is this Harvard Law School piece on the legal aspects of DAOs. It's not too old. It's from last year, and contains some interesting insights into not really the solutions probably to legal aspects, but how some DAOs are handling it, and what regulatory frameworks are coming up in that regard. So I kind of recommend that. And Vitalik, of course, should not be forgotten here. He every now and then he has his opinion on voting and how voting should work. And here's a piece on token-based voting that he did some time ago, which I can also recommend. But it's quite lengthy though. And with that, I want to finish. And if there are any questions, I think you don't have any chance to ask here. But I want to thank you for listening, and hope you got some insights into how DAOs work.
Okay, thanks for Claude's sharing, and I think that's all for today's, right?
Yeah.
Great.
That's all.
Great. Maybe you can share me the links you showed in the workshop, and I can attach it under the video. And thanks all
Yeah.
for today's joining our today, and hope to see you again next workshop. Bye bye.